Hey there, viewers. Welcome to our meteorology segment. Thanks for tuning in and congratulations on realizing our channel exists. We're starting things out looking at lightning, as lightning is one of the ways that Earth weather can kill you. But really, what's more important is lightning shows us where storms are. Check out the storm track of this system here. It's moving almost due south from Kentucky straight into Tennessee, as opposed to moving west to east, because the jet stream is not in charge of the atmosphere over most of the U.S. right now, folks. Although we've got some cool weather coming into Pennsylvania, making it a little bit more temperate here. Next, lightningmaps.org to look at the real-time lightning map, and we did stream this video live, by the way, to twitch.tv/smAsho. And here's the terrestrial lightning scenario. Hey, Nashville, this is probably going to miss you, but go out and take video of these cloud tops. From your location, you may see sprites and green elves and all kinds of pink jellyfish and weird stuff happening above the clouds. Make sure you take photos and video, even if you don't see it, as the UV emissions from upper-level lightning is largely not visible to the human eye. Although your camera probably can see it. Anyway, quite an active lightning scenario going on as we make the video. Continuing on to talk about how you're killing people with your carbon emissions, right? More carbon emissions will kill more people. And somebody did the idiotic math of the mortality cost of carbon. Yes, carbon is allegedly killing people now. And somebody's done some ridiculous math to quantify this. Check it out. Assuming that the emissions continue to increase on their current high path, he came up with a number, 2.26 times 10 to the negative fourth, or 0.000226 excess deaths this century per metric ton of carbon dioxide emitted beyond the current rate of emissions. Now, this assumes that carbon dioxide is in charge of the Earth's climate, which is complete nonsense. I mean, crack a geology book. Everybody who claims that carbon dioxide is in charge of the Earth's climate. I've been studying this formally since 1987, okay? In 1987, I took 8th grade Earth Sciences. I was told then that by the year 2000, most of Florida would be underwater. Are you viewing the videos from Florida? Are you underwater yet? How come all of these catastrophic temperature forecasts aren't coming true? We should be at like 3,000 degrees, according to what James Hansen was idiotically saying in the mid to late 80s. So this is complete nonsense, and I just figured I would just put the article up here, which is a complete sharticle from phys.org. It's a sharticle calculating the number of deaths. So here we go, folks. This is how many people you're killing. 0.33 people per capita. Oh my God, you're killing 0.33 people. Wait. This number compares unfavorably. I'm not even going to spend any more time on this nonsense. I'm going to direct you to our terms defined playlist. So if you're viewing the video any place besides YouTube, go subscribe on YouTube. And our terms defined playlist includes a video about the sharticle. So the sharticle actually specifically cites phys.org because phys.org's Earth section is rife with sharticles. So check out our playlist, youtube.com/smashamash/playlist. Let's get back to some legitimate weather data here. And look at the massive anticyclone here in the southern Pacific and the huge pressure gradient. So this is a huge high right here with lows on either side of it. So some massive pressure gradients happening there in the southern Pacific, Southern Ocean, and around the Drake Passage here. One of the weirdest places in the world is right here, folks, the Drake Passage, as water must slosh back and forth between the Atlantic and Pacific Oceans through this narrow waterway here called the Drake Passage. It's quite a strange place, and without getting any more into the geophysics of that, there's where pressure cells are currently. We'll advance this into the Euro forecast for tomorrow. This is the Euro forecast for pressure at 12 noon tomorrow. That's Eastern Daylight Time. Continuing on, here's the weather.gov map. And some excessive heat here in the southeast. So that's all excessive heat warnings and watches and so on. Some flood watches continuing in the western portion of the country. And a lot of fog happening here in the central portion, the upper Mississippi Valley, I'll say. Next, looking at jet streams. And once again, convective forces are largely in control of the U.S. weather. So the jet stream's making it down to the mid-Atlantic states a little bit here and the, New England and so on. But largely convective forces remain in charge. So that's part of the reason why that system is moving from Kentucky into Tennessee instead of moving west to east. Let's look at surface winds while we're looking at the western portion of the planet. There are surface winds, and let's rotate to the east. Here's the eastern world. Strong winds continuing in the Southern Ocean here. As winter rolls on, here are the jet streams of the eastern portion of planet Earth. And we've got some backward jet stream once again over the western Pacific and central Indian Oceans. Chaotic jet stream flow in the northern hemisphere, a little bit more coherent in the south. There is the North Geographic Pole, and you can see how chaotic and meridional the northern hemisphere's jet stream flow indeed is. Next, the weather.gov. This is radar.weather.gov, the U.S. Doppler radar map. And it looks like those systems are going to stay east of Nashville there. Some heavy rains moving across South Dakota. Anyway, that's the Doppler radar. Here's the cloud layer. It's too dark to see the clouds with a visible satellite, so we use the 3.9 nanometer radiation map. And we encourage our viewers to be able to forecast the weather. So maybe we'll do a tutorial video about this at some point. Use the water vapor map if the Doppler radar is not helping you out. So when you look at the Doppler, it may be showing deceptive things happening. It may not tell you how a storm system is going to move. When that happens, break out the water vapor map. It will usually give you an indication. And a quick little tidbit for you here. Dry massive air like this is more massive than this moist air. You may think that all that water in the atmosphere has more mass than dry air, but a clear day has a higher pressure than a cloudy day, and it all has to do with the molar mass of atmospheric nitrogen versus dihydrogen oxide, known as water. Yes, water much less massive than nitrogen, which is why humid air is less dense than dry air at a given temperature. Anyway, here's your recap. There's the U.S. Doppler radar. There's the cloud layer. And there's the water vapor. By the way, the entire lower portion of the U.S. is a massive anticyclone right now. You can see a bit of a clockwise rotation here. And in the northern hemisphere, that means anticyclone. It's associated with overall high pressure. Anyway, thanks for tuning in to today's meteorology segment. Hopefully you haven't read too many sharticles and believed too much nonsense about carbon dioxide being in charge of the Earth's temperature. That's complete nonsense. Seriously, crack a geology book. Anyway, signing off, I've been your host, Dan, a.k.a. smAsho. Signing off from the Smash News Network, least busted name in news.